Okay, guys, we have a MacBook Air. Um, it's already disassembled. It's an 820 Is that what it is? Let's see. So 2013, 2014. The board number is was the board number again? Okay, under the SSD. Let's take out the SSD. 3437 should be 3437. Let's just confirm that. My head is quite full right now. And I just okay, yeah, it is 3437. So that's the board number. I hope you guys can see that. It's 820-8437. So 3437, that it's 2013, 2014. So one of the components to where you can differentiate between a 2013, 2014 board and a 2015, 2017. Number one is the JTAG connector. The JTAG connector, physical difference, the JTAG connector will tell you. So the 2013, 2014, the ones that obviously, so the reason why I'm not mentioning 2012 is because 2012 won't even fit in the same shell as that of a 20 you cannot use a 2012 board in the shell of a 2013, 2014, but you can use a 2013 board in the same shell of a 2014, 2015, and 2017 MacBook Air. So one of the ways you can differentiate between the 2013, 2014 and the 2015, 2017 is the JTAG connector. The physical difference now. So the JTAG connector of a 2013, 2014 is going to be bigger, and that of a 2015, 2017 will be smaller. So this board is a 2017 board. Now this is a 2017 board. Now if you look at physically, you can fit in a 20 you can fit in a 2013, 2014, but in a 2015, 2017 shell with everything is going to work 100% the same. Now physically, one of the physical difference you can tell the difference are the JTAG connector. So 2014 and 2015 and 2017 you have a smaller JTAG. 2013, 2014 you have a bigger JTAG. Now the BIOS chip, which is the SPI ROM chip, the SPI RAM chip for 2013, 2014 is going to be bigger. So this is the SPI RAM chip. This is the SPI RAM chip for 2013, 2014. And this is the SPI RAM chip for 2015, 2017. You can see that the SPI RAM chip is smaller in terms of size. Now another thing is the webcam processor, which is this. You will see that on this is not like a unique identification when it comes to the webcam processor, because so usually the webcam processor, you find that oftentimes the 2017s they use the look of, it's almost is identical, is identical to your SMC chip or to your RAM chip. So I'm talking about the RAM processor now, but the RAM processor for 2013, 2014, this is how it's going to look. And 2015 will also look like this. So that you shouldn't really worry about using that as an identifier. So the identifier you can use, the board numbers are not going to be the same. The board number for 2013, 2014 are going to be the same, 80-3437. The board number for 2017, 2015 are going to be the same, 80-00165. However, when it comes to the physical identifiers, what I say is, so look at the SPI ROM chip, which is the BIOS chip. The 2013, 2014 is going to be bigger in size, and the 2015 is going to be smaller in size. Now, the JTAG connector as well, you see that the JTAG connector for this is the 2013, 2014, but the JTAG connector is going to be bigger compared to the JTAG connector of 2015, 2017. So on the MacBook Airs, you will not find 2016. You will only find 2013, 2014, 2015, 2017. So this is a 13 inches board. Yeah, so that's pretty much. So this board is a 2017 board, but the 2013, 2014 is going to fit exactly into the same shell as this will fit in. And then something else I want to say is you can as well look at um, the the configuration of the board. Say for example, this is 1.7 and it's 8 gig. Now this is a very rare configuration for 2013, 2014. Usually the configuration that you will get on this will be i5 and 4 gig, but this is i7 and it's 8 gig. So and usually on the 2017s and 2015s, usually you will find that the 2015s the sticker on this is filled out. The 2017s will be 1.8, and then the 2015 will be 1.6. So usually that so so this is 1.7, but on 2015 usually you find that 2015 will be 1.6, and then 2017 will be 1.8. So now let's come back to this board and why we're here. So this logic board, what it does is it automatically switches off. So it switches off by itself. So there has been some kind of a previous work, I suppose, in the area of the CPU, because the behavior is such that you will almost think that the issue is CPU related, but that's not the case. The issue is not CPU related. So the board has already been taken out of the shell. So what we found is this. So we found, uh, I'm not sure if you guys can see that. So this section here, it's corroded, and then usually this can be formed. If you have a machine in a very cold environment, uh, I mean, this can. So this is not like an active liquid spill. No, not like there was an active liquid spill. So this is actually built up over a period of time. So let's look at this section of the board and see why that is important to why the device switches off. So in order for us to fix this, basically what we need to do is we need to uh, remove and replace, readdress that section of the board. So that is important. Let's open up the board view of the machine. It is 3437. Um, okay, let's open up that. 820 Okay. 3437. So it's you find 3437A and 3437B. So what we have is 37B. Yeah, that is what we have. So, um, so um, this is the section of the board that it's. I'm just gonna put back the SSD. I had taken it out. So when I'm working on these devices, especially if I don't have a reason to remove the SSD, I do not take out the SSD. And if I do take out the SSD, so usually what we do is we kind of put in some kind of identifier on the logic board so that it doesn't get mixed up, because I mean there are a lot of boards and a lot of repairs to do. So for example, you say this is written MT, so that every part of it will be written MT. Every part of this device will be written MT, so just for us to identify which is which. So I'm putting back the SSD right away because we're not working in this section, so there's no need for me to remove the SSD. Now the section of the board that is affected, it's just gonna show you guys. It's Q8550. So what is Q8550? Let's open up the board view here. Sorry, the schematic Q8550. Uh, it is 3437. Um, okay, Q8550. Q85. Is it 8550? I don't think so. Let's see. Uh, Q8150. Okay, Q8150. Q8150. So we're basically searching for the component. So let us see why that is important. So now in our Q85, so Q85 8150, see what it is. It says BJT version SOREL E good. So I'm just gonna do this. Yeah. Now this is critical to the overall function of the machine. As you guys can see, it says there critical. This is critical to the overall function of the machine. So when you have an issue here, definitely the machine is going to misbehave. So what we want to do is we want to remove and replace, address that section of the call so that the device does no longer. Afterwards, we hope that the device will no longer work and switch off. The device will work smoothly without having to switch off. So, first thing we want to do. So, I'll just show you guys. So, not only is the chip itself affected, we can see the resistors around it. That obviously these are the combination of the overall function of QH150. The resistors around it are also affected. So we want to take out the components in that region and also replace. So my problem now, so the thing with this form of damage is the components are not only eating up, the parts of the components are also eating up. And most importantly, it's the parts, not because the component can be replaced, obviously, but the pads are what you kind of worry about because the pads are eating up, and now you have to manually recreate the pads. Okay, all of the components are out. You guys, all of the components are out. See, so now what you want to do is you want to clean that section, recreate the parts, and then replace the components. Usually in a repair like this, my worry isn't the components. The components can easily be replaced. My worry is always the pad itself. So the pad where the components will sit is always my worry because the pads get eaten up. Uh, so we will clean the sections, then we apply solder, and then we can replace the components. Okay, so this is how it looks now. Now, I'm not worried about focus. Is it focus? So I'm not worried about this section of the board because this is not populated. This is not. This is no stuff. There's nothing here. I'm not really worried about this. Sometimes I may have to worry if, for example, we have a pad that is running through any of this. Then I may have to worry to have it redone. But I know there is no pad that is running through this section, so I'm not really worried about this section. This is only the section that we're worried about. So now it's been cleaned. The next thing we want to do is we want to apply solder, and then we want to get a donor board to get the components from. So another thing also we want to do is, you can see the shining part of the board. That's where we still have solder present, and then you have this section. For example, there is no solder. We need to apply solder. So what you want to do is you want to get a donor board to compare to see exactly how, what components and what has been affected, so to say, that needs to be taken over to this section. And then yeah, and then that's basically what we need to do to complete the repair. So let's get another board to get our components from. Okay. Okay, so this board has all of the components that we need. You guys can see that is that's um, focus, yeah. Uh, so that has all of the components that we need. I'm struggling to get into focus. Okay. Struggling to get into focus. Okay, yeah. So it has all of the components we need. So let's start. Another thing we will be also looking out for is continuity in terms of to be sure that the pads, I mean, to be sure we have continuity between one component and another, because most likely you might have a broken via. So we want to make sure also that we have continuity across. So let's pretty much get get it sorted, and then yeah, it should be done. Hello? I'm taking my time, so because the pads obviously, yeah, the pads were almost non-existent. So I'm taking my time to some of the pads, not all the pads. Taking my time to make sure they're well recreated. Now let's put back the components one after another. I have to hurry up. It's almost time for Salah now. Okay. This is. We still need to clean the section, but so far this is how it look. Horrible, yeah, I know. This is struggling to get it to focus. We're not obviously going to leave it like that. We will clean it up. So now what we want to do is we want to confirm the lines are intact. So we have to confirm the line one after the other. So let's see this. So we will need to confirm that pin 5 of Q8150 and um, pin 2 of R8153 is connected because we see they are tied together, this and this. So now we use our meter continuity mode to confirm that they are still intact. Okay, what I'm gonna do is I'm just gonna remove Q8150 to make it easy to measure. So after I confirm that the lines are healthy, then I can put back Q8150. So first, pin 5. Pin 5. Okay, that's a bit. Pin 5, it's fine. Okay, now let's see. Now, R8153, let's see if we are connected to. Okay, let's see if these lines are healthy. So now we need to confirm that the lines are healthy because there's a chance that there's a broken pad. So if we have a broken pad, this circuitry is not going to work. So what we're trying to do now is we are trying to ensure that the lines are properly still connected. So that's what we're doing now. Components are put back together. We are now confirming the health of the lines. So now let's see if RET153 is still properly connected to the rest of the circuitry. And yes, it's still connected. So now let's see. Okay, R8151. Let's see if R8151 it's connected properly because R8151 it's basically almost like the start of the circuitry in terms of the NPDC. That's where we have our 5 volt 9 SO going into it. So let's see if that is still present. Okay, it's still okay. Now let's see. We have confirmed that this is fine. Let's now move on to R8156, pin 6 of Q8150. See if we have connectivity between pin 6 and pin 2 of R8158. I'm just gonna move it a little bit closer for you guys to see. So pin 6 of Q8150 has to be connected to pin 2 of R8156. Let's see. Okay, and it's connected. Now the next thing we want to confirm is um, pin 1 of R8156 if it's connected to the other section of the circuitry. Yes, it's connected. The next one is pin 7 of Q8150 and R8154. We want to confirm if pin 7 is connected to pin 2 as it should be. Yes, it is connected. Now let's say it's pin one of R8154 connected to the other section of the circuitry. Let's confirm that. Yes, it is connected. Now, the reason why we're doing this is if it's not connected, the circuitry is not. If there's a if there's a broken via or if is a broken pad or if there's a break in communication, the circuit is not going to work as intended. So now let's check R8157 to see if we have connectivity to our pin 3 of Q8150. Okay, yes, we have connectivity. And by the way, we are using continuity mode because once we hear the beep, it tells us that we are measuring on the same path like this. So when we hear a beep, we know that we are on the same path. So without a beep, then we definitely know that we have something is wrong. So pin two is unconnected. That is not used. So let's go to pin one. Pin one should be connected to R8155. Let's see if that is the case. Yes, it is connected. Now, also, pin 8 is not used, so we're not going to worry about pin 8. Now, let's look at pin 4. Is pin 4 connected? See if our pin 4 is still connected to the other section of the circuitry. Yes, it is connected. Okay, now let's put back Q8150 and test the board and see if the board starts. Yeah, let's put back. Okay, so this type of repair, pretty much you want to see if your board even starts. I mean, if should your board start, you are good. I mean, if it doesn't start, you have to again look into your circuitry to be sure that everything is still connected the way it should be. So so one thing I want to say, another, in case you guys are working on a 2013, 2014 board and you notice a strange behavior on the fan, don't worry, it's not a problem. So what behavior am I talking about? When you connect a charger to a 2013, 2014, 13 inches MacBook Airs, the fan will stop, start again, start for the third time, and then continue rolling. That is not going to be the behavior of a 2015 and 2017. That behavior is only on 2013 and 2014. 2012 won't even do it. 2011 won't do it. It's only 2012. It's only 2013, 2014 that you will experience. The fan will start again, start again, and then it continues for the third time, and then the machine will then start. So if you have a MacBook Air 2013, 2014 that you're working on the board and then you connect to the charger and then you see your fan starts and then it stops, don't think you have a quarter fan spin. You don't have a quarter fan spin. You are good to go. The 2013, 2014 board behave that way. So right now what you want to do is you want to connect our charger. This is hope that it starts. Let's hope that the board starts. So pretty much should the board start and then I get a display, then I'm pretty much okay. Then that my repair was successful. So what you want to do, we want to connect our charger to see if our board starts. And by the way, because we do not have our IO board cable connected, so you will not get the LED on your charger. So don't expect to get an LED on the charger. Okay, that's good. So let's see. It starts. We expect it to stop because if it doesn't stop, it's also a problem. Okay, that's good. Let's see again. Does it start? Okay, that's the second one. We want it to stop because if it doesn't stop, it's a problem. That's good. And then the third one. Um, Okay, now it mustn't stop because if it stops, then there is a problem. So the third time, it should not stop. Okay, that is good. The fan is running and it's not stopping. That is good. Now, guys, so if the board had started one time, and then second time, and then instead of it to stop and start for the third time, if it had started rolling off from the second row of the fan, then that's a problem. It shouldn't do that. And also sometimes if you have a 2013, 2015, 2017 board, sometimes when you see the fan starts and then it stops and then it starts again, that's the problem. That is not a simulation, or that is not a similitude to a 2013, 2014. The 2013, 2014 body is supposed to behave the way you guys saw it. The fan will start and stop, the fan will start again and stop, and then the fan will start for the third time and continue rolling. So what you want to do now is you want to see if we have uh, um, an image in our screen. We want to see if we have a display image, and then yeah, let's just see if we have an Apple logo. I'll get the display now. Okay, guys, I'm gonna run now because it's time for Salah. I'm just gonna test it for you guys to see that we actually have an Apple logo, and then I can leave. So I'm gonna test it, clean it up, and then yeah. So let's see if we have an Apple logo. Okay, uh, started. Finally started. Initial. It should stop. Start again for the second time. It should stop, and then start again for the third time. The third time, now this is when the device is supposed to start in terms of getting your chime. Okay, so let's see, do we have okay, let's see, we have an Apple logo. Okay, that is an Apple logo, and we are loaded. So thank you guys. That's going to be the end of this repair. So um, the board is going to be cleaned, put together, tested, and the client can collect, and that is a happy client. So yeah, pretty much that is what we had to do. I wouldn't really have time to go into re-explaining and the procedures that we took because I need to go for Salah. Yeah, I'm just gonna clean the board real quick, and that will be it. Someday, guys, I'm gonna teach you guys a technique on how I clean the board. Like it looks really dope. The way I do it. Yeah, but not today. I need to be quick here because time is not. I need to be quick. Uh, I'm using tissue, but the board looks dead afterwards. You don't want to work on a board, and it's so obvious to everyone that you have work there with flux everywhere. Okay, that's it. See the way it looks. Yeah, it's all board. Uh, that's it, pretty much. Thank you guys. See you in the next video.